we'll work through solutions to, well, let's see how far we get in 10 minutes anyway, because that's the limit of the YouTube upload. So alright, let's keep our formula sheets to one side and kick off into the kinematics. Okay, question 1, list the following terms as being vector or scalar and include the unit of measurement. Velocity is, it's a vector because it has magnitude and direction, and it's measured in meters per second. Distance is just a scalar, it just has a magnitude and that's measured in meters. And displacement is the vector, and that's measured in meters as well. Convert a speed of 28 meters per second to kilometers an hour. The conversion factor is 3.6 to get from meters per second to kilometers an hour. We multiply by 3.6, so that means we need to put 28 and multiply that by 3.6, gives us 100.8 kilometers an hour. Alright, over the page, an apple is dropped from a height of 1.5 meters. Circle one or more of following statements that are correct. Acceleration increases, no it doesn't. Its acceleration is constant, yes, well it's subject to gravity, which is constant. Its velocity is constant, no, it will be increasing in speed, and its acceleration will not decrease. So B is your answer. Question 4, the world record time to complete the men's 1500 metre running race was set in 1998 at 3 minutes 26 seconds. What's his average speed of the runner in both metres per second and kilometres an hour? Okay, let's work in metres per second and we'll convert that afterwards. So our change in distance is 1,500 metres, and our change in time is 3 minutes. So we do 3 times by 60 seconds in a minute is 180, and 26, and that equals 206 seconds. And we know the velocity is change of distance over change in time. So that's 1500 divided by 206. 1500 divided by 206 equals 7.28. Let's call that 7.3 meters per second. And don't forget, they're asking for kilometers an hour as well. So that's 7.3. If we times that by 3.6, we get kilometers an hour, 26.28 kilometers per hour. So there's our 2 answers that were asked for. Okay, continuing on. Okay, so getting some values off a graph here. The graph below it shows how velocity varies with time for a car travelling in a straight line in a westerly direction. Fully state the car's velocity 10 seconds after starting its motion. 10 seconds is there. So, its velocity is 20 metres per second west. 20 metres per second west. Fully state the car's acceleration 10 metres after starting its motion. Okay, 10 seconds. So it's this, and this is a constant gradient, and the gradient of a velocity time graph is acceleration. So we need to work out the gradient of this part. So gradient is rise over run. The rise of this part of the graph is 40, the run is 20. 40 divided by 20, 40 divided by 20 equals 2. And this is acceleration, minus 2. And it has given us a direction, so let's use it. Fully state usually alludes to a direction. Okay, question 7. What distance does the car travel in the first 30 seconds of its motion? Now we cannot use our kinematics equations here. We can't use these here because the acceleration is not constant. Never forget that we can only use these formulas here when our acceleration is constant. And the gradient of a velocity time graph is acceleration, and we can see that that gradient definitely changes. Okay, so to find the distance, the area under a velocity time graph is equal to the distance travelled. Okay, the area under a velocity time graph is equal to the distance travelled. So this is what we're going to use here. What distance does the car travel in the first 30 seconds? So we want to find the area of this. Okay, and we can see that we can break this up into some shapes we can deal with. One triangle, one rectangle. Beautiful. Triangle is half base times height, that's the area of a triangle, plus base times height of the rectangle. So it's half times by 20 times by the height, which is 40, plus base times height. The base of the rectangle is the difference between 20 and 30, that's 10, and the height's 40. So 10 times by 40. Okay, we did 0.5 times by 20 times by 40 equals 400, plus 10 times 40, no prizes for guessing what that is. 10 times 40 is 400. 400 plus 400 is equal to 800. 800 what? 800 metres. Okay. Questions 8 and 9 refer to the following. A catapult runway on this aircraft carrier is 83 metres long and accelerates an aircraft at a constant rate of 36 metres per second. Okay, constant. So that means we can use these formulas here. So let me just write up here, x equals 83 metres and acceleration equals 36 metres per second. Okay, starting from rest, we know what that means. That means that u equals 0. Starting from rest, what speed is the aircraft doing at the end of the runway? Well, that means at the end of the runway it will have travelled 83 metres. We know the acceleration is 36 metres per second squared. What speed is the aircraft doing at the end of the runway? So we want to find the final velocity. So there you go. U, X, A and V is our unknown. So we're looking for a formula with U, X, A and V. U, X, A, no, we can't have T. So that's out, that's out, that's out. So it's this. V squared equals U squared plus 2AX. V squared equals U squared. Okay, so you see what I've done? I've written the formula. Now I'm just substituting them in, not taking any shortcuts. 2 times by acceleration is 36 times by x, which is 83. Okay, v squared equals 0 times 0 is 0. So we're left with 2 times by 36 times by 83. 5976. 5976. Okay, then we need to square root both sides to undo the square. And we square root that. V equals 77.3 metres per second. Okay, so that's our metres per second. And to convert that to kilometres an hour, we times by 3.6 times by 3.6 equals 278.3 kilometres per hour. Okay, very, very fast. But we are talking about a jet launching off the end of an aircraft carrier, so I can feel fairly confident that it has to be a big number, otherwise